Good morning, everyone. I am Dr. Ruma Patel, Associate Professor, Department of Computer Science and Engineering, Jhuleland Institute of Technology, Nagpur. Uh, I am presenting a lecture on computer network. The content that I have to cover in my lecture is physical layer and media, analog and digital signals, analog and digital data, transmission modes, serial and parallel transmissions, asynchronous, synchronous, multiplexing and multiplexing, and communication medias. Now, first is what is analog data? Analog data refers to the information which is continuous. Analog data take and continuous values. For example, an analog clock which is having hour, minute and second hands that gives information in a continuous form. The movement of the hands are continuous. Sounds made by human voice. What is digital data? Digital data refers to information which has discrete states. Digital data takes a discrete values. The example of digital data is digital clock which reports the hour and minutes in the digital format. Data are stored in computer memory in the form of zeros and ones only. Analog signal. The features of analog signals are it uses a continuous signals. It also gives the real world representations. It has a smooth transitions and complexity. It is a more complex than digital systems due to the need for additional circuitry to process and transmit the signals. The features of digital signals are it uses a binary code, that means a combination of zeros and ones only for representation. The accuracy of digital systems are more than analog system because the information is represented in a precise and consistent manner. Processing speed of digital signals are quickly and accurately, and noise immunity. This is the basic difference between analog signals and digital signals based on how the signals are representation, how the transformations are done. Transmissions required flexibility between analog and digital signals, noise problems, power consumption, waves, and some examples of analog and digital signals. Now the next point is transmission modes. Depend on the direction of data exchange from sender to receiver and synchronization between the transmitter and receivers and how the bits are transmitted in the network. The transmission modes are divided into different categories. First, depend on the direction of exchange of information. The transmission modes are divided into three categories: simplex mode, half duplex mode, and full duplex mode. Depends on the how the synchronization of bits between transmitter and receivers are done. The transmission modes are divided into synchronous and asynchronous manner, and the bits are sent simultaneously or asimultaneously. The data transmission mode is divided into serial and parallel transmission. What is basically the data transmission? Data transmission is nothing but a process of transferring data between two or more digital devices. Data is transmitted from one device to another in analog or digital form. Basically, data transmission enables devices or components within devices to speak to each other. Data transmission mode is divided into two categories: parallel data transmission and serial. And again, serial data transmission is divided into asynchronous, synchronous, and isochronous. First is serial transmission. The serial transmission mode is a mode in which a data bits are sent serially one after the other at a time over the transmission channel. It needs a single transmission line for communication. The data bits are received in synchronization with one another. So there is a challenge for synchronizing the transmitter and receiver. In serial data transmission, the system takes several clock cycles to transmit the data streams. In this mode, the data integrity is maintained as it transmits the data bits in a specific order one after the other. This type of transmission mode is best suited for long distance data transfer, or the amount of data being sent is relatively small. For example, data transmission between two computers using serial ports. This is the basic representation of serial transmission. The advantages of this transmission, it is uses a long distance data transmission as it is reliable and stable, but the number of wires and complexity requirement is very less. It is a cost effective also. The disadvantages of this transmission is it is very slow due to this single transmission channel, and throughput depends on the bit rate. That's why automatically throughput is decreases. Parallel transmission is a transmission in which the data bits are sent parallelly at a time. In other words, there is a transmission of n bits at the same time simultaneously. Multiple transmission lines are used in such mode of transmission. So, the multiple data bytes can be transmitted in a single system clock. But it is normally used for short distance communication only, because for n bits transmission we need the n different transmission lines. So the complexity of the network increases, but the transmission speed is high. If two or more transmission lines are too close to each other, then there may be a chance of interference in the data, degrading the signal quality. The example of this type of parallel transmission is between data transmission between computer and printer. This is the basic diagram of parallel transmission. The advantages are more than serial transmission. It may transmit n bits simultaneously. The data can be sent from computer to printer using the parallel transmission. The data is transmitted significantly more quickly in parallel transmission, but it works for short distance only, and set of bits is transferred at a same time. The major disadvantage of this parallel transmission is it requires multiple communication channels, and communication lines must be utilized to transfer the data stream. That means there will be a requirement of n number of wires. It is costly because it is usually confined to small distance only. The wire thickness must be raised to reduce the signal loss when transmitting data over long distances. Now, the next one is synchronous serial transmission. As the diagram shows, the synchronous mode uses a synchronization of bits, direction of flow from sender to receiver in synchronized manner. The bits are sent one after the another without any start or stop bits or gaps between them. Both the sender and receivers are paced by the same system clock. In this way, synchronization is achieved. In the synchronous mode of transmission, bytes are transmitted as blocks in a continuous stream of bits. There is no start and stop bit in the message block. The receiver counts the bit as they arrive and group them in a 8 bits unit. The receiver continuously receives the information at the same rate that the transmitter has sent it. It also listens to the messages even if no bits are transmitted. The example of synchronous serial transmissions are CPU, RAM, etc. The advantages of this type of transmission is it is very fast as there is no gap between the data bits, but it is very expensive also. Now this diagram represents asynchronous serial data transmission. In this mode of transmission, the start and stop bits is introduced in a message during transmission. Start and stop bits ensure that the data is transmitted correctly from sender to receiver. Generally, the start bit is 0 and the end bit is 1 is used for this type of transmission. Asynchronous here means the asynchronous at a byte level, but the bits are still synchronized. The time duration between each character is the same and synchronized way. In an asynchronous mode of communication, data bits can be sent